Everybody, this is Ed. I'm going to explain how the divide and conquer algorithm works um, when you're trying to find the maximum subarray. I'm using C++ and Xcode to compile my code. So let's jump right in. So I have a main method right here, and I'm going to try to find out what is the maximum subarray in balance. My array called balance. It only has two elements, 3 and 9. So it's easy to tell what the subarray is going to be. It's going to be 12 because that the subarray includes all the arrays inside your array. So the way this is going to work is we're going to use the divide and conquer strategy. So the divide part is going to look at the left and the right half of the array. So first it's going to check the left, and then it's going to check the right here, and it's going to keep on dividing the array. So it's going to do that through recursion. It's going to keep on dividing, looking at the left half, looking at the left half, until you reach the base case where there's only one element in your array. So this is the base case. So high is going to be the highest index, and low is going to be the lowest index. So by assigning high to different values, you're going to be able to reach that base case. And we're going to talk about that in a second. All right. So we're going to call our function maxSub from the main method. We pass in our array the starting low index. We want it to start at 0, the beginning, and our high index, which is 3. And I found that through the size of the array, -1. Okay, I'm going to run my debugger so we can go through this code together. All right, first time through, we are going to run into left low right here. We haven't reached the base case yet because high and low are not equal. High is equal to 1 and low is equal to 0. But we calculate the middle of the array, which is high plus low divided by 2. And that's going to equal 0. So as you can see, when we're trying to divide the left half of the array, we're going to substitute the middle index for the high, where the high is supposed to be. So that way, we're only going to be looking at the left half of the array, and it's going to get smaller and smaller until we reach our base case. So just to demonstrate that, let me step into this function. So you can see that when it calls itself again, it's going to run into the base case because mid is equal to 0. So now remember, this is where the high goes. So high is 0, low is 0. So we reach the leftmost half of the array when we're, the leftmost index of the array. All right, and we get the leftmost element, which is 3, as you can see here. All right, we reached the base case, so we're going to return to the conditions before the left low was calculated. So those conditions were, so now that we return to the beginning, it's going to look at the right half of the array. So you see it's going to go into the right high part. And this is a little different than left low because we're going to be substituting the middle where the low used to be. So that's because we want to look at the other half. So this way, we're going to get everything to the left of mid and everything to the right of mid. So recursion is kind of cool because once it finishes calling one part, it's always going to return back and finish doing what it was. Finish in this case, it's going to finish the right half of it. So let's step into that. So mid used to be 0, we added 1, so now low is 1 and high is 1. So the base case is going to execute and we're going to get 9, the rightmost element. Okay, so this part is the combine, is calling the combine function, and the reason we have this is because once we find the maximum subarrays to the left and right, we want to find out what the maximum subarray is that crosses the middle index. So here's how we're going to do it. So we have the middle, which is 0, the high is 1, the low is 0, and we're going to kind of look at each side respectively, first the left side and then the right side. So we have the mid here, and whatever we pass into low is going to serve as the lower boundary of our for loop. So we're going to calculate, we're going to increase the sum as we traverse the left side of the array. And we will update the left max variable if the sum is greater than it. So that way we only update it if we're getting, we're going to always end up with the maximum sum by doing that. So we do the same thing with the right half of the array. And we need to create another variable called rightmax to store the right side. Sorry I went through that kind of fast, but once you run both for loops, you just add together the maximum on the left side and the maximum on the right side. All right, so our combine ended up giving us a value of 12 right here. Obviously, when we go through the if statements, we're going to compare the different return values that we got from the left side, from looking only at the left side of the array, only at the right, and also looking at the combined side. So as you can see, left side is 3, right side is 9, combined is 12, so we're going to return the combined because it's the biggest. And let's see, voila, program ended with exit code 12, so it gave us the correct output. And in this case, the maximum subarray was basically the array we passed in. Of course, this is a very simple case, but if you run it with bigger arrays, it's helpful because it uses recursion to divide this big task into easier, smaller tasks. Okay, I hope you learned something. Please let me know if I made any mistakes and I will correct them. All right, and have fun coding. Bye. Well, I knew how to exit this thing.